to be talking about series and parallel resistor in series and parallel. So this what we have here is a resistor in series. When a resistor is connected in series, the resistance increases, thereby making the current um, to be small. So this is because the the total resistance of this resistor is a sum of all of them. T will be equal to is a sum of all the resistor. So now using the Ohm's law, which is um, this, then to calculate the current is equal to R over V over R, which is the same thing as sum of these. This can be the total of all um, the resistor. Now, when we look at the parallel resistor connecting in parallel, what you notice here, what you observe here is that by connecting resistor in parallel, it decreases the resistance, making the current to be high. So in that case, to calculate the total resistance, we'll use, it means that a fraction of each of them, sum of all the fractions of each of the resistance, that will give us the total resistance. Now, using the same Ohm's law, since we know that I is equal to V over the total resistance, then what we do here is, in this case, is that it will be equal to V multiplied by that will give us the current we are looking for. Now, another thing we're going to be looking at some questions that will help us to really apply some of this. Now, resistance in a circuit, resistance can be connected in different ways. It can be parallel series, multiple of ways. So we're going to look at some questions that will help us to really apply this in how to do the calculations with all this. Now this is the question that we have that we're going to use to understand or digest the explanation so far. Here we have 6 ohm resistors. We are to find the minimum and the maximum value of the total resistance. Here again, the V1 said that total resistance when connected in two groups of parallel resistors. Now, the other one, we talk about total resistance when they are connected, two in series, two in parallel. Now, let's quickly look at this. Remember, the question will be seen in the description section of this video. So now the first one, you know that, like we stated earlier, the minimum value of the resistance of the total resistance is achieved when it's connected in a parallel. So what it means here is, since we have 6 ohm resistor, it means that the minimum will be equal to total, that is, total will be or perhaps let's just go straight. So we have 6. 1, 2, 3, 4. Add up together, we have 4 over 6 equals to 1 over. Then this can go to this one, will give us 3. Now we'll have 2 over 3. Crossing over, we have arrow 2 equal to 3. Therefore, arrow will be equal to 3 over 3 over what? Over 2. That will give us approximately, that should be, our decimal fraction will be 1.5 ohms. Or approximately we have one whole number 1 over 2 ohms in fraction. All right, this is what we have. The next one we're doing there is the maximum value. If we're dealing with the maximum value, the maximum is achieved. Note, the maximum is achieved when it's connected in series. That is, total is equal to 6 plus 6 plus 6 plus 6. This will give us 12. Then 24 ohms. So this is what we have as the maximum. So the next one we are going to do now is to calculate, say that total resistance when a group of what connected in two groups of what parallel resistors. That means what is telling us here is two groups of parallel resistor. That should be like this. Don't mind my drawing, you know. Don't mind my drawing. Oh, that's just all right. We are there now. This is 6 ohms, another 6 ohms, another 6 ohms, and then another 6 ohms. That is, he said a group of two in parallel. That means parallel to each other. Now, before we solve this thing, the first thing we do here is to resolve them. We have to resolve each of these things. If we are to resolve it now, this one, if we bring them together, what we have here will be, this other one will be oh, sorry. I will give us 2 over 6. 2 over 6, that will give us 1, and then 3. Then the inverse arrow will then be equal to what? 3 ohms. So the next one is also 3 ohms. Then now this one is 3 ohms, this one is 3 ohms from here because they are all the same. So now what we have is now in series. We have something in series here now. This one is 3 ohms connecting to another one which is also 3 ohms. This is 3 ohms. If we sum it up, if we resolve them, then the total now 3 plus 3, we have 6 ohms. That is what we have for this. So the next one, the question there said that total resistance when they are connected with 2 in series and 2 in parallel. So what we do again, come back here. That should be our last question there. So if 2 is connected in series, and another one 2 is in parallel. This is 6 ohms, 6 ohms, 6 ohms, and then 6 ohms. Now this place will give us this total resistance altogether can be 6 times 6 over 6 plus 6. I think we can still get the same thing. This will give us 12, and then 6 times 6 will give us 36. This will give us, let me see what we have here. 6 times 6 is 36, I'm sure. Divided by 12, we still have 3. Yeah, we have 3 ohms. And then the next one is these other ones, the series one. We've solved the we have succeeded in solving the parallel. So the series now we have total in series. That means 6 plus 6. That will give us 12 ohms. Then total resistance 12 plus 3. That will give us 15 ohms. So that is where we'll call it a day. I will encourage you to subscribe if you have not subscribed, if you are joining us for the first time. And then if there's any question you want to ask us, feel free to leave it as a comment. And then remember to share. We want to see you again in our next video. Thank you so much.